Good afternoon and welcome to the Electric Utilities panel discussion at YII20205. My name is Brad Johnson. I'm the Director of Electric Utilities for Bentley within our Industry Solutions Group. I'm really excited to bring a panel to all of you today to have a global discussion about the various issues, challenges, and I think some really great optimism we can have around electric utilities globally. We've never seen so much change happen in such a short period of time. Thinking about, as I said last year, 100 years of work to do over the next 10. And as I was reminded recently in Brisbane, it might be more like 140 years worth of work. Earlier today, you got to see examples of how Bentley is bringing innovation to life for our user community. But one of the things I'm most excited about is how practical that innovation is in the daily work of our users and how impactful it will be as they work to keep up with the rate of change. So today we're going to talk about many different issues. We'll be talking about how AI benefits us as an industry in answering the call that's being made to deliver more and more energy while retaining reliability and sustainability in our grid. We're going to be discussing other issues around policy. How do we adopt this technology? We want to make sure that it's a global discussion. So as you are hearing us speak today, I encourage you to think, lean into the discussion, and at the end we'll have an opportunity for questions from our audience as well as our welcoming in our remote participants. So with that said, I would like to welcome our panelists to join me here on stage, and we'll go ahead and get started with our lively discussion. All right, Stephanie, Mark, and Savannah, come on up. We can get comfortable, right? It's just us talking today. First, thank you all for joining us here in Amsterdam for our event. This is a great opportunity for us to connect with our users, with our industries, share what we're working on, but then continue that discussion with those in our industry. So what's happening? What's happening at your feet, and what do you see? So if you guys are okay with it, we'll just jump right into the dialogue.
Let's do it.
Sure.
All right, sounds great. So I wanted to start it out with a little bit of reflection. You know, the last few years have been a lot of acceleration in our industry globally, and it's manifesting different ways around the world. So, you know, what would you say it would be a big shift that you've seen occur in the industry? And, you know, how do you believe the shift is changing the way that we design, build, or manage reliable, sustainable delivery of power? Stephanie, why don't we start with you?
Sure. So if you'll give me just a moment, I'll do some table setting first. So I work at Georgia Power Company. It's a subsidiary of Southern Company, which does provide energy services throughout the United States. But my focus is really the electric piece in predominantly the state of Georgia, where we are privileged to serve about a third of Southern Company's customers, so nearly 3 million customers statewide. And so with that said, we are also, from a model perspective, how we engage in the industry, we are vertically integrated and state regulated. So what that means, and I'll build off it through the conversation, what that means is we are, the vertically integrated piece, we are responsible for serving customers everything from the energy production all the way down to the end-use customer. So we make decisions that are optimal for customers throughout that entire value chain. We also are regulated at a federal level as well as a state level. And so we do go to our Public Service Commission elected officials for approvals of those plans for those investments. So with that said, I think one of the biggest shifts that we see is, again, just back to that model, it's a convergence of where, you know, technology and customer demand for the way it's interacting with the grid. A lot of that is around new technologies. So as an electrical engineer, I call them inverter-based resources. So the electronics, the power electronics, and how that plays into, you may call them renewables or clean generation, right? Battery storage, solar, wind. That's a new dynamic to the grid, and how we integrate those reliably is a changing dynamic, as well as what do we even define as a potential energy resource? So energy systems and production in general is becoming more distributed. So if you've heard the term DER, or distributed energy resource, that encompasses not only the types of technologies I just mentioned, but also what are you putting in your home and business? Solar panels, smart thermostats, EV charging, microgrids. How are we optimizing all of these things that our customers are using and rethinking the way that we are planning, designing, and operating the grid. So that's the biggest shift, but I know that's kind of a lot.
It's
everything from customer demand all the way to production.
Yeah, it's a large, big shift. There's
Right.
so many different aspects to it. The engineering side, what does an inverter-based resource do to managing reliability? It's a lot. So maybe it's a big scale of everything all at once.
That's right.
Yeah. Mark, I know that your organization has a global footprint and global point of view. What do you see that's changed a lot?
So when you think about the global footprint and how different each region is, and different sizes, different issues, different just pain points, the one thing that, especially listening to the keynote this morning, and you heard two words said a lot, AI and data. And those commonalities, using different platforms, different softwares between yourselves and some of your competitors, sometimes I think people need to take a step back and think, maybe the actual software isn't the main issue. It's how do you gather the data, make that easily accessible amongst the different regions, give context very similar like Stephanie. I work for an engineering consulting firm, Burns & McDonnell, and we have just different issues in the different regions that we help support. So the two commonalities that we really try to focus on is data and the workflow. To me, if you focus on those two things, that helps solve the problem whatever region you're in.
Right. Yeah, and it's amazing how much data is a capital asset these days, right? To make the right decisions, to learn from what you've done, and how do you make sure that your team in one office is learning from what's happening teams in the other? It's data. It's that common language.
Exactly. And then we're going to talk about it a little later, but hiring the right people.
Yes.
To work on, to access that data, to improve the workflows, to standardize those workflows, and then use the technology that's given to us.
Yeah, and I think there's been a lot of change certainly in Europe, and what's happened with the European market, where energy is coming from, how it's moved around, how do you continue to maintain reliability? What are you noticing, Savannah?
So kind of maybe bringing it back to the Mile High perspective, because I'm representing the European power sector. So we're based in Brussels and we work on EU legislation. And I can't be in this room talking about reliability, visibility, and all of this without talking about what happened on the Iberian Peninsula back in April. So we had a massive outage that came as a result of a lack of data sharing between the transmission and the distribution level. And so having things in place that can facilitate that more, increase the transparency, and then also, I have to talk about DSOs as the unsung hero there, because they're the ones that really brought the system back online, because we have so many distributed energy resources like we talked about. And the role of the DSO is, becoming much more active in Europe compared to in the past when it was super top down. So we'll talk about it a little bit more, but that's kind of what we're seeing from the European perspective.
Awesome. And for those who don't know, DSO, distribution system operator.
Yes.
I sometimes I said TSO and DSO, and they're like, oh, you mean DNSP? And yes, yeah. So, and it's a great example of where it's not just about sharing insights; it's about sharing the engineering grade data between these organizations. A black start of the grid is very complicated, and I think a lot of people became very acquainted with just how hard. You don't just push a button, turn it back on, right?
Yeah, absolutely. And hydropower kind of got to be the unsung hero in all of this. And when I was talking to one of the engineers that helped with the Black Start in Portugal, he talked about it kind of like as a symphony, right? So you're bringing in the right people at the right time, all in harmony to a point where you can get the whole system online. And the fact that they were able to Black Start in 12 hours is pretty incredible. But I imagine with even better tools and systems, first of all, we could prevent it from happening. But in case it happens again, we can get the system online that much faster.
Awesome. All right. Yeah, and I think that's a great lead into my next question, Stephanie. We're going to come to you here. So, Georgia Power has made major investments on transmission and the distribution systems through the grid investment program. Can you share a bit about how those efforts are helping the company continue to modernize? We've talked about the migration of data centers down the East Coast. Maybe talk a bit about that, and how also thinking about the existing built world, how is it helping address that aging infrastructure?
Yeah, so I mentioned our regulatory structure before. So we have a requirement by statute. Every 3 years at a minimum, we come back to our commission. We file a plan that addresses the next 20-year forecast and how we're going to serve the growing needs of Georgia, as well as then 6 months later, how are we going to fund this plan, right? What is the cost to our customers, to our ratepayers to fund it? So in that rate case, we call it that funding plan, we talk about the transmission and distribution budgets, and this plan that you mentioned, the grid investment plan, is part of that discussion because it's a step beyond our traditional transmission distribution investments. It is focused on very specific things, right? Aging infrastructure for transmission, and then for distribution, reliability. Because distribution, not to assume everybody's background in the room, but those are the smaller wires that go to most of your homes and businesses versus transmission, the big towers that we see here. So in that distribution, that's what most of our customers know from a customer experience and reliability perspective. They're focused on that. And so that plan has been through multiple cycles, now regulatory cycles, and we have, in the way that we addressed it, back to data, we've used a lot of data analytics to inform, okay, let's look at, especially on the distribution side, the reliability for each of these distribution circuits or lines, and look at those worst performing ones and see, okay, why are they performing poorly compared to other circuits throughout the state? And what kinds of investments would we need to make? And so that's kind of the premise behind what this plan focuses on the distribution side is how should we address the reliability that is worse for these customers in these parts of the state? Should we maybe reconfigure the system? Should we add some smart grid or automated reclosing technologies? Should we go underground because there's a lot of trees? Maybe we don't have the rights to cut the trees in the area. So those are the types of investments that we make, and it could be a combination for each of those circuits. And what we've seen so far is a 50% improvement. In the last 6 years that the program's been going, it's 50% improvement for reliability, both in duration and frequency of outages for customers along those circuits, which used to be some of our worst performing, right? So in improving that customer experience, and I'm going to say transmission too.
All right,
transmission just a little bit. As we talk about serving, you mentioned data centers and growth. I mean, we want to optimize what we have already in the field. So whether it's, can we squeeze a little bit more out of a transmission line, so dynamic line ratings, or could we use a right-of-way that we already have and maybe just replace the type of conductor with something that can carry more capacity, an advanced conductor? Those are examples of investments in technology to maximize what we have out in the field. So they're part of grid enhancing technologies, if you've heard that GETS term. So those are just other examples of investments for improving the customer experience by maximizing what we have.
Yeah. And I think that gets to the heart of what motivates a lot of engineers and why, as people say, what's the utility space like? Well, you'll find out when you enter it, but you'll never leave. It's a bit of a Hotel California for those music fans out there. Because what we do really does directly impact quality of life in so many ways. And I think that's underlines why it's so important, the work that we are all doing as a community to do these things that improve quality of life for those folks. And I think that's maybe an opportunity, since you opened the door on the Iberian Peninsula, to turn from a your electric perspective. What do you see are those opportunities? You mentioned better collaboration on the data front between the DSOs and TSOs. I think that's a great call out, especially in that scenario. But IBRs, the integration of more and more renewable, but also other forms of energy production where appropriate. How do you balance all these competing priorities and still remain reliable and affordable?
No, I mean, that's a big question because DSOs for a long time were just a carrier, right? They're bringing energy down from transmission into homes and businesses, but now they're being asked, okay, you have to do smart charging for electric vehicles. You have to provide flexibility through heat pumps. We're now electrifying 50% of industries on the distribution level, and we're asking them to be flexible to boot, which not all of them can be. So you have to manage these dynamic flows of energy that you've never had to before at a time when in Europe, 30% of the grids right now are past their useful lifetime already, and that number jumps to 90% in 2050 if we're not acting quickly now. And it's also a system which can't go down. I mean, Iberia was the really good example where a 12-hour outage led to 2.5 to 4.5 billion euros in lost economic activity, and somebody's going to be on the hook for that cost too, by the way. So, you have a huge penalty when you go down, and you have to make sure that the system remains reliable. So From a policy perspective, what we're asking for is recognition of the investments in technologies that can help us get there, because we need to make the best use of our existing assets for as long as possible, but also we have to invest in digitalizing the system, making it more reliable, especially on the low voltage level. That's where we have like the lowest level of visibility right now, and it's where we need the highest level of investment, because it also has the highest impact on our customers. Because if the low voltage goes down, that's, you can't heat your kettle, you can't cook your dinner,
Right.
you can't run your washing machine. Like, that's going to be the biggest problem. So, we need to utilize flexibility, of course. That's a good way to do it. We also have to improve planning and permitting. So we've got a legislative package coming at the end of the year this year, where we're going to ask for some streamlining on the planning and permitting side to have a better communication of data between the actors. And then, of course, we have an issue with connection queues. I think this is a global issue as we've got more and more people coming on board. So, asking for a mandate to move beyond first come, first serve, to still treat our customers in a non-discriminatory way, but maybe say for some of those speculative applications, we can kind of clean them out and they can come back once the project actually comes to fruition.
Yeah, and just to underline global perspective, Stephanie, you and I were at an event last year, very North American centric, and that whole idea of how do you prioritize things as they come in and out certainly manifests in the North American market as well.
Oh, absolutely.
And where policy is changing to, how do you define a large load customer, and, how do you change these things? And I think maybe what I'll do is turn it the other way, because we've been talking about a lot of like really large things, is, Mark, I'm trying to think of how, I want to rephrase this a bit. There are these regional differences, but there's also regional similarities, right? And like I said, your organization sees things through many different lenses, and as you are a technology leader within Burns & McDonnell, how do you see us crossing these borders? So the conversation that we heard about Data Center Alley and what's happening here in Europe, is there a role that you can play or your organization plays, or what are you seeing, I guess, is how do we bridge these gaps between these different regions so we can all learn from each other?
I mean, isn't that where Bentley comes in?
I suppose so, yeah.
I mean, that's
Here we
part
are, yeah.
Part of why we're here. I mean, yeah, I think we haven't really broached that subject, AI, right? I mean, I think when we talk a lot about how this is integrated, like again, referencing that keynote today, a lot of great speakers, a lot talking about the technology that's coming. And so seeing the differences, whether it's internationally, whether it's utility companies, engineering consulting firms, we're all trying to solve very similar problems. Mm-hmm. And so what's the commonality that we all are seeing? And really, how are we, I think I was talking to one of my peers last night, and I kind of made a joke about like, hey, anytime you hear those two key words, data or AI, add that to your bingo card. Look how quickly will that fill up. But I think you have to take a step back and think it's not just about adopting AI, it's about adopting AI strategically. Mm-hmm. And that's really what's important to all of our roles, because it's here, it's coming. Whether we're doing it internally or we're utilizing software that's got it embedded. And I think that is a very key factor in how we're addressing any of our issues moving forward.
So it's a very thoughtful and impactful way to adopt AI, automation, data insights, rather than just for its own sake. And I think it's interesting, we're in an industry where AI is on both sides. It's generating the demand, and it's going to directly help us. It does impact other industries, but I think utilities are unique in that we're hit so hard on both sides, but both as an assistant in growth, but also in helping us solve these problems. And I think that is a very common thread in the conversations we've had, like visits to Australia and India, et cetera, is like, this is driving a lot of that sort of thing. So I think, Stephanie, I'll turn and we'll get more specific. So I was going to hope that maybe you might have a specific example at Georgia Power where technology has helped assist or drive Georgia Power's mission forward.
I'm going to give you two.
Oh.
Because we were just talking about AI.
We'll do two, yeah. All right.
So from an AI standpoint, we have, you mentioned strategically, right? So the data piece, we've looked at several parts of the business, and one recent success that we just rolled out is actually in the area of storm response. So, storm response, we call it SPEAR. I forget what the acronym is, so don't ask me, but it means something around storm reporting and estimated time of restoration. And so one thing we're doing with this tool, which has been rolled out across Southern Company, is you see a storm coming in, right? We have a lot of thunderstorms, of course, hurricanes in the southeastern part of the United States. So you see some of these predictive models, which are just predictions, sure, but based on past historical storms and damage, we can try to predict then what kind of outages do we think we're going to have in terms of volume? Where do we think they're going to occur? And how severe do we think they may be? You know, you look at winds, for example, that can tell you how many broken poles, for example, that you expect to have because you know your design criteria. So you can look at those things and predict. So that's data analytics, that's AI, so that we can stage material, people, equipment, proactively in some cases, depending on the situation. And then, once the storm comes through, of course, it's different than the model. So how do we need to adapt? And then what does that adaptation in terms of how quickly we can get people, materials, equipment, all those resources to the locations that were hit hardest, what does that mean in terms of their restoration time? So all of this, because we want to provide that out ultimately to our customers, right? We want to let them know when we think the power is coming back on and do it as safely and quickly as possible. So all of that changes the workflow. Some of these things were happening anyway. You had people who had maybe been going off of gut feel, but now we have real data, which is great. I mean, not that their gut wasn't good. They've been doing it for 30, 40 years, but they're retiring too. Our workforce, that goes back to the workforce piece, is turning over. So how can we do that more consistently? Second one, though, with the substation rollout, this morning, and we talk about data centers. So one of the biggest challenges from a utility standpoint is ensuring not only that we have the capacity to serve, but that it's reliable. And so we are not going to invest in serving new customers at the expense of either cost or reliability to our existing customer base. And so I share that to say data centers, AI load in particular, operates differently. It's very, it can be very volatile, a lot of oscillations, which makes it difficult to ensure that we have high degree of power quality to all existing customers. It's not just serving them at their site, but it's also the existing customers who are interconnected to that grid at a large scale, right? So those are some of the considerations we're bringing into our design criteria. Do we need to consider flexible designs that allow within the substation footprint, whether it's new or existing, the ability to add maybe some mitigating power electronics equipment, such as batteries or STATCOMs or static synchronous compensators, to account for the volatility within the way that they're interconnecting and acting with the grid. So.
Awesome. Well, I appreciate the segue, because the next question will be for all three of you, and I think, Mark, we'll start with you. I have to say it, I was super excited to see the announcement this morning for Substation Plus, to see two engineers working so closely together, where that is, globally, it's a challenge that every designer has. And it's not just in substations, it's in other forms of infrastructure as well. But I think I want to kind of turn it all to all of you, and like I said, we'll start with Mark. On the substation side, anything that just popped to mind about how you think that's going to help? You have a lot of engineers working there at Burns McDonnell. How do you see something like that helping your teams?
Yeah, you brought up a great example, is working collaboratively. I don't want to speak on behalf of every engineering consulting firm or every utilities, but at times we work in silos. The different business lines, the different groups, civil will work in their workflow. You've got your electrical, your relay and control, your physical, transmission, pipelines. They're all working in silos. And then at the very end, you're all putting everything into one model or one federated model. And so seeing what us being one of your partners in helping pilot Substation Plus, the reason we wanted to be involved is we know what's our biggest pain points every time we're designing for clients such as Georgia Power. And so how can we work together or partner to find out, because at times, we have competitors, we have clients, we have mutual clients too, but how do we make our clients successful? I think that's our biggest mantra, and that's collaborating and figuring out what the pain points we have and the way we execute and design every day, and seeing that example or that demo of where we were and where we. So when I was designing back then, it was not like that. I mean, MicroStation J was the very first version that I worked with, so that might be dating me. But seeing the technology nowadays, and then, I mean, COVID probably brought up having to work remotely. You know, when we sent everyone home, I remember sending the team home. I said, "All right, see you in 2 weeks." it was not 2 weeks.
Well, longer than 2 weeks, yeah.
And that kind of forced us to have to figure out how to centralize the data and work remotely, and that really helped us, especially in our international offices.
Yeah, when that happens too, I'd imagine the normal over-the-wall chatter that was happening before that was driving collaboration. Well, you can use other tools to do that. It's not quite the same. And when you're doing follow the sun sort of work, where projects have an urgent deadline or something, you have to have tools that enable that real-time and asynchronous collaboration among the teams. And Savannah, you brought up something, by the way, I'm so grateful that from a policy perspective, we're looking at technology like a capital asset, like buying new, better equipment now, right? Because it is intended to enable these better outcomes. Is there anything that jumped out to you this morning?
So the word that I focused in on the keynote this morning was people. So what I thought was really great is that a lot of the conversations that we have around AI and workforce is how AI is going to replace people and we're going to lose jobs. But what I like about this product is that it's actually making people's jobs better, allowing them to work in a more efficient way, and it's automizing some of those tedious tasks, right? So you don't want to be sitting there looking at all of the pictures and designing every single inch of the existing structure. If you can have AI do that for you, that's great, and you can go in and make the modifications that you need and work with your team at the same time. So for some of our members that work internationally, that's super useful to also compare between the structures. So if you're working in North America, Latin America, and Europe, you can see the differences and maybe have some lessons learned on how to do things better. So I would say that's definitely the part. And from a policy perspective, it is moving away from this like CapEx bias, right? So here in Europe, we have now more of a toe tax approach in the law. It's got to be implemented. That's another question. But basically what distribution system operators are asking for is to have these investments recognized, because they're going out there, they're already saying, we need this innovation. It's going to make us better. We're going to invest in this. But now we need to recover those costs so that it's not for nothing. And so that also, that technology gets scaled, so our bigger DSOs can move first and spend a little more money because they have a little more money, and then that technology can then be also available for our small and medium-sized members as well, so that they're able to benefit from all of this advancement.
Awesome. I think, Mark, later I'm going to come back to you on the smaller utility size for some perspective there. And yeah, I think the people centricity of a lot of this is really important. And I've heard that fear elsewhere where engineers, and I think there have been some past examples where, not necessarily in our industry, where they saw automation come in and it was creating that perception, but very intentionally, this is, if nothing else, not just impacting the quality of life of the customer or the member of a co-op and the reliable energy, but how do we also take a little bit of pressure, that little edge off the engineer so they can focus on the precision that they're usually so very, very committed to. So Stephanie, I'll turn to you. Anything that jumped out from you from this morning's keynote that you want to highlight?
Yeah, I mean, I'll just underline some of the things. So we, from a design standpoint, we do that across several states in Southern Company. So that is a centralized function for us. We also work with several contract firms. And so back to the collaboration, ensuring consistency for our customers, which I'll tie it back even to storm restoration for a minute. We restore our electric grid together across Southern Company, also with other utilities nearby, but across Southern Company, our standards are the same. That's what we've been working towards. It's taken a long time to get to that, to where I can even say that. But that said, we are able to procure material at bulk, right, and we're able to stage it more effectively and efficiently. But that takes a consistent design capabilities, right? And you want to make sure the quality is the same so that when we send crews from Georgia to Mississippi to help restore, that they can expect the same level of quality and design in the way that it's executed. So I think, just to underscore and give an example on how important that is to getting the lights back on sometimes, it's critical.
I think maybe in the future we should do a mutual assistance panel and talk about how this is going to make that process a lot easier as well.
It's all the above.
Yeah. So thinking about policy again, there's an act, the AI Act, and each country is kind of going through it, as may be said, with AI. And the AI Act is what we're seeing manifest here in Europe. So how do you see that as being that catalyst? I think utilities sometimes don't always want to be the first mover. Some people raise their hand and want to be first movers, which is really great. But how do you see vehicles like the AI Act helping?
Yeah, so I mean, on the one hand, we're not sure how it's going to affect the sector because, of course, the AI Act covers all artificial intelligence. So this is everything from large language models down to what we use in the system where you're analyzing photos to see if you have damage that you need to go repair, right? So AI is such a broad term now, it's difficult to say. But from our side, it can serve as a catalyst as long as the approach is not too conservative, right? So, we know that we're critical infrastructure. Electricity is what we need to power our lives. But at the end of the day, some of the uses of AI in the system are pretty benign. They're not going to cause a lot of issues for the system. They're just going to make things better, more reliable in the end. So making sure that we get that right. Unfortunately, in the EU, it's never just one act, but then we get all of the subsequent secondary legislation, and then it all has to be transposed at national level. So we've still got a long way to go on this, but at least when it comes to saying what a safety component is in the system and what is an actual high-risk application of AI, that's going to be the determinant for us. So, things like algorithmic trading or predictive maintenance, maybe not high-risk applications in the system. So just making sure that the energy sector has, again, it's all about access to tools, right, and the right tools, and making sure that they can apply them in the system without having this overburdensome regulatory compliance side of it to the point where they say, okay, it's too expensive, I'm just going to stay with my SCADA system, run everything manually, and, have to pay an extra, 1,500 people to do it. Right. So I would say it has an opportunity to be a catalyst, but it depends on what comes next.
Yeah, I think clarity, to me, in moments like this from a policy perspective are very impactful. And maybe you can tell me your thoughts on this from a clarity perspective as somebody who's in policy within utilities. Is that valuable? Like how does because I think the last thing anybody wants to do is do something that runs afoul. So I think opportunities like the AI Act, I think some of what we see happening policy in the U.S. Anything you'd want to add, like clarity around policy, is that helpful? I'm assuming it's probably helpful.
It can be.
Okay,
I'll say, so I mentioned we are federally regulated as well as state regulated. So, and Mark, in terms of the regional differences, that applies to policies too. Because our market structure, back to, I mentioned vertically integrated as well, that's not the case in majority of the United States. So recognizing that, not all policies should fit equally. So we do talk at a federal level about the regional differences because of that market structure and the clarity. But in general, right, clarity for us comes not just at the federal level, but at the state level. I mentioned, our grid investment plan we were talking about before. It's helpful to know where our commission is because it goes to rate recovery because we are making these investments on behalf of customers. We have clarity, therefore, that our commission and their policy decisions are aligned, and we can know that it will be recovered, right? As long as we do it in this way, that as long as we're filing the compliance, whatever auditing they want to do, we can get guaranteed recovery for those investments. So that kind of clarity is very helpful.
Very important, yeah. And I think, Savannah, turning back to you on the regulatory side, that clarity, you're operating in an environment that acts as one, but also acts as many. Just briefly, anything you'd say about how that impacts this? I mean, the grid does cross country borders, but stays within the commission's remit. Anything you'd want to add to that?
Yeah, so it's also the difference between how transmission is treated versus how distribution is treated. So here in the EU, transmission, it's usually one TSO per country, and they're a national monopoly, and they get treated, but they do have certain rules that they have to follow at the European level, including how much interconnectedness they have. And so it's important that we have that reliability across the board, because when we've got extra hydropower production in Switzerland, for example, it's really good that it can go over to Germany when they're having what we call Dunkelflaute, which is when the sun's not shining, the wind's not blowing, and we need additional other energy resources. So no, it gets a bit complicated, and I like using the EU and the US as kind of a mirror of each other, because when you're both federally and state regulated, it's the same in the EU. You're supranationally regulated by the European law, and then you have to figure out how that fits into your national regulation, or in this case of like large member states like Germany, also at the regional level, and it gets super complicated. So the clearer it can be in the European regulation, the better it is for all of us.
Clarity, clear communication, insights from data, this all kind of bundles together, I think, because I think one feeds on the other, and so on. So we'll maybe ask a question for all three of you. pivoting a bit to the workforce, we talked about the human factor a little bit earlier. So this is a digital transformation. The grid is evolving, the grid is transforming. The way we do the work is transforming. It's becoming increasingly technology-centric in the way that it's done. So with it moving so fast, with AI causing culture shifts, and as I was saying, I think we were having a side conversation earlier, how people's expectation at work is coming from what they experience at home with technology. Savannah, we'll start with you on that. Anything that you would say from that perspective on how this is all manifesting, for regulators, for engineering firms, and for utilities?
Yeah, I mean, so I would say it's one of the rare cases where utilities are moving first and they're asking regulation to kind of keep up with them. So what we found in our study Wired for Tomorrow was that it's not an issue of a lack of technology. The technology is there and we're already starting to use it. It's just a matter of regulators recognizing the value of those technologies, what they bring to the system and to their customers. But then also within the utilities, doing this change management exercise of, okay, we're going to move away from paper to more digital systems, and we're going to be working on things that are more complex than we used to before. But the good news is we have all of these tools at our disposal. It's going to take a little bit of training and a little bit of a time, but most of the utilities that we work with have invested in their people, and so they want to continue and maintain that trajectory so that all of the people that are working there can have fulfilling careers and have also these transferable skills, right? So maybe they work in one part of the industry now, but 10 years later they might shift to another part of the industry, and all of that information, stays with us.
Yeah, it's funny. I think earlier I said how people enter the industry but they don't leave. The other part that I forgot to mention is that the thing that will change is their business card. They're going to do a lot of different things as they work in this industry, and I think that's an excellent point that you raised there. So, Stephanie, anything you'd like to add?
Yeah, I mean, so the AI panel just a little bit ago, a couple hours ago, I think it kind of raised a few things that I took note of, in particular, best practices to make sure that we're integrating AI in the right places. We talked about strategically, what does that really mean? And so we've looked at, across Southern Company, we've looked at, okay, can we centralize some of these functions? Can we centralize some of the use cases and the investments in the technology to solve multiple problems across the business? So from an organizational standpoint, we've made some changes so that we have these functions become more centralized so that they can serve across the border. And then also, kind of the people piece of it that you were mentioning too, one of the suggestions that I think really resonated with me was the fact that our people, we would call them champions, right? Allies that are within the work project teams themselves, having those data scientists, having some of our data analytics folks in those projects from the beginning, because they may, as we talk about ways to either start something new or reimagine what we've been doing, they can help us get it right from the data part on the front end,
right,
and see if there's an AI solution or is it data analytics, how can we make this as streamlined as possible. So just thinking about who we have and the way that we're structured so that we can do that has been helpful.
Yeah. Brett, can I add to that?
Yeah, absolutely.
So at least from Burns & McDonnell's perspective, my role didn't exist 5 years ago. We just hired a CIO, Chief Innovation Office. That didn't exist, right? Hiring full stack software developers that are part of, as Stephanie was mentioning, part of the project teams are now commonality in our company. So when you're talking about people, I mean, one thing that we haven't really talked about is, we talked about AI is here, but it's how we're interacting with it. Something that I haven't heard a lot is about, we're training our staff prompt engineering. How do you interact with, whether it's ChatGPT, Gemini, Copilot? If you're not asking the right questions, you're not going to get the right data. Mm-hmm. So we want to train our staff, upskilling them to understand AI is not going anywhere. Mm-hmm. We have to train you how to structure your conversation with large language models so you're getting the output you really need.
Yeah, it's a foundational level culture change. I'm guessing Burns & McDonnell, long history. Yeah. If you think about those early days, did they even contemplate something that would be like a data scientist back then? Not. And it's just the industry continues to change and evolve. I'm excited for that. I mean, some people say I'm bright side it, but that's going to draw more people into our workforce, which is something that we so desperately need, is more of that gravitational pull, so that people can see how exciting it is to be, a data scientist, a well, I think you call it prompting, prompt engineering, those sorts of things. So, but sticking with you, Mark, for this question, I think it's really easy to see how this impacts large-scale enterprises. But there's also a lot of small utilities out there. Municipal utilities, cooperatives, PUDs, and then other forms all around the world. Anything you would add to bring this home to those smaller entities?
Yeah, it'll just be to piggyback off what I was mentioning. Is you say small utilities, even smaller. I probably shouldn't say this out loud, but are smaller competitors, right? I mean, AI. You're mentioning a little bit about the people and AI. I've said this a lot. Is AI is not going to replace people. That's not the goal. But AI will replace people who don't use AI, right? I mean, if you sit back and think about it, like when we're recruiting in universities now, it's like we ask what their experience is with AI. We ask if they've taken a software development class, because those are the key people. But to go back to your question, it's going to equip smaller utility companies, smaller engineering consulting firms to be able to take on larger companies like us. If we're not going to continue to evolve, we are, FYI, we're evolving. But if we weren't, the small mom and pop shop, they could do just as much, if not more, if they're equipping themselves. But and also to piggyback off that, like Burns & McDonnell is about a 15,000 person organization. T&D is about close to 4,000. Us, you mentioned change management, us to just pivot a little is a tall task. Now, if you have a small, nimble engineering firm, they're very agile. So I probably said way too much about that at Burns & McDonnell, but it's what's out there right now.
Yeah, awesome. Well, I think we just have a few minutes left before we turn to our audience for questions. So I'm going to close it out with one final question. And before I do, though, when we talk about data, I think it's important for us as an industry who is very much around precision is not to let perfect be the enemy of good. If we wait for it to be perfect, it'll never happen. But if we highlight where there are imperfections in our data and we raise that level of awareness to the users, then they may not be as fearful talking about adoption to bring it online. So just throwing out there, just remember, perfect should not be the enemy of good. Anyways, so the final question, and I think, Stephanie, we'll start with you. The crystal ball is there, right? What's your one big, bold prediction for the future? What do you see coming? And attached to that, what could we as an industry be doing today? So I'm going to put you on the spot first, because Mark's had a little time to think.
So I'm going to go back to the distributed energy resource. I mentioned that was a huge shift. We're doing a lot in that space in terms of what are we doing today. There's still a lot of room to go to fully optimize the potential and the value that those types of resources can have. So I'll give a little more color. What are we doing today? Across Southern Company, we are investing in a distributed energy resource management system, DERMS, to optimize the use of those different assets, those resources, so that they can truly be resources for reliability, for capacity, in aggregate. If you've heard about demand side management, that is certainly valuable at the right time. So there's a lot of different value streams. But first, you have to have some certain capabilities. You need to know what's out there. You need to be able to forecast how you can use it. You need to be able to control it. And so I share that to say we're doing a lot today where I'd like to see, my bold may not be as bold as you want, but it's still going to take 5 to 10 years to do this, is integrating that realization, the full optimization capabilities that will enable, bringing that into the real-time operations scenario and making sure that our operators are part of that too. And we have talked about the importance of that, but there's no one fully doing it at a grid scale today. You may do it with certain assets and smaller pieces and parts, but not at scale like what we're talking about and where it needs to go. So bringing that into the real-time decisions.
More and more.
That's right.
More and more. Mark?
I've got a bold one.
All right.
Everyone here use Amazon, right? Everyone buys stuff in Amazon. Imagine having, doing that for substations, where you go to a website or you go to some web platform and you're just, how much design's out there where you just click a button that says add to cart, and it goes straight to construction and you deliver. I mean,
So Bentley.
I'll be retired by then
Okay,
if that
so-
happens. But
So bentley.com/substation/buy now.
oh yeah,
I love it.
Just you just click buy
Substation in
now.
a box.
Yes.
Absolutely,
Yeah.
absolutely. That's pretty bold, right?
Plug and play.
That's bold. I like it. Savannah?
I think just to bring it back to AI and how it's going to be transformative for the energy sector, I think that's going to be the big thing, and it's going to be, as you mentioned at the beginning, both sides of the coin, right? So demand is going to significantly change. We're already seeing it significantly change the system, but we're going to see, I think, it go even more, especially as data centers can become more flexible, and we can use AI to leverage that flexibility to make the system better. On the other side of the coin, though, how AI is going to change things for us as operators, I think it's going to be, optimizing the system, making better use of the data that we have available, being able to share that data between different places. We didn't get to talk about it today, but interoperability, I think, is going to be a big thing that AI can help us with, figure out where are those commonalities and get our structures in place. So I would say keep your eyes here for the next 2 years, but also policymakers, please give us the money so that we can do it. Otherwise, we're going to be stuck with the same system for the next 50 years, and that just won't serve anybody.
Change definitely takes investment. It takes capital investment. It takes time investment. It also takes personal investment towards putting your own time into making it happen. But definitely not forgetting about the funding of these programs. So with that, we'll turn it to you here in the audience. So both here in person and remotely, if you have a question, raise your hand. We have somebody with a microphone who can bring it to you so you can pose that question. If you're online, feel free to submit your question in the chat. We have somebody monitoring that right now. So anybody have an initial question they'd like to ask the panel today? Yes.
Cameron Franson from Environment Analyst. Thank you for a great session. I have a question for Mark. So you mentioned earlier on that the right workflows can solve some of the challenges around AI and data integration across different regions. What would you say are some of the kind of universal principles that make that possible when you're looking at these systems, in different countries and trying to get that extra value out of data and AI?
That's a great question. I think a lot has to do with, we kind of talked about is like how you interact with AI, because I assume we're not the only company doing it, but creating chatbots, creating actual AI agents. And if you're, we always think about, we have these more senior engineers that are retiring. How do we get all that data out of them and put it in? All these training sessions, that we do internally, externally, all these conferences, right? Imagine being able to, imagine this is happening now. You're creating these bots, you're creating these algorithms. It's going to be as smart as you want it to be, So when you create those, you create workflows, right? So I assume people have seen, like if you look at social media, having different AI agents talk to each other. They're interacting with each other. That's really what's coming up next. So now when you get all those different agents that are happening, how are we utilizing them? How are they acting as QA, QC, and what we used to do manually, printing out drawings. I don't do production anymore, but I remember printing out all these, Mylar drawings and just marking it up, blue, red, and green, what they mean. No one does that anymore. So when you talk about improved workflows, it's already happening. I think I mentioned COVID. Before, I don't think anyone in our production team marks drawings up anymore. They use different software, whether it's Bluebeam or Adobe. That's a good example of an improved workflow. So whether you know it or not, it's already happening. It's just a matter of continuously improving. And we talked about how we have different regional offices in Burns & Mac. Some are smaller, some are bigger. The smaller offices, most of them are doing multiple jobs, right? But how do you just standardize? So maybe it's not even improve workflows, standardize the workflows. So now what we're doing in a larger engineering firm, if you show those workflows to a smaller engineering firm, they can execute just as well as we can with the technology added on top of it.
Excellent. Thank you. And we have another question right up here front.
To piggyback off of that, it sounds as though you all have to face pretty complicated regulatory environments that come from lots of different levels. If you're able to move that quickly on technology, how do you do that with the regulatory environment looking down from the other end, right? none of the governments I've ever dealt with are anywhere near as technological as you guys are, right? So how do you convince them that they need to be moving faster to approve workflows or whatever, you're dealing with from a technological level?
You go first.
Sure, yeah. From the European level, so our association works a lot with the Association of the Regulators, and then there's an agency of the Commission that deals with this. So we work to have really good bilateral relations with them to help them understand, but we also host a lot of technological workshops. So where we bring in our utility experts and we say, here's what we're working on right now, here's what we're looking at, here's how it improves the system, here's, we don't do like a traditional cost-benefit analysis, right, because that would take way too long and it's too subjective, and nobody believes us even when we do tell them that the benefits outweigh the costs. But what we can do is show them what's out there, what's possible, and what the benefits are, and that usually is our greatest weapon, is providing more knowledge to them. But that's kind of our role as an association, and we kind of help the utilities with that. But I don't know how it is working actually in the utility space.
Yeah, I mean, I think a lot of that resonates too. We do that at a state as well as a federal level. More so at the state level, again, they're the ones officially approving the plans as long as they abide by the federal principles. So we do see, I think it goes back to more that compliance, that auditing function that they provide a benefit. We're working AI into being able to respond to them, but in terms of, what you were just mentioning, Savannah, I think there is an expectation that part of that documentation does define and run through a cost-benefit analysis for these investments. And so I think it's really more, your question, I think I understood it to be more, how can they, from a policy standpoint, be able to be more enabled through AI? I think it's more they're asking for information. In my perspective, they're asking for information that we're better enabled through AI to produce at a pace and with the thoroughness, the level of detail that they really need and require, so that we can hopefully, justify in a meaningful way to them and provide them the information they need to feel good and confident that this is the right decision that they're making on behalf of all of our customers and ratepayers. So that's how I see it really playing into our conversations and being beneficial in the regulatory sector.
And one thing that I think I've been impressed with, especially over the last few years, just thinking about on the U.S. side, even a bit on the Australian side when I was just there, and some announcements made in Western Australia, there's more collaboration and communication between industry and the regulators. Seeing, FERC and CERC sitting next to each other on a panel and talking about issues with utilities in a common language, with a common understanding and a common goal. The more of those settings where they're working collaboratively, some areas it's a little more adversarial than others, but I've seen a surge in that collaborative mindset on both sides of that coin. And the more that happens, the more clarity there is, the more dialogue there is, the faster that we're all going to get to solving these problems together. Because I think engineers, that's in those of us who support them, that's what we want to get to, is solve these problems faster and faster, and that clarity and communication is so key. So I see that we have a submitted question up here. So the question is, and this is a great question, how can we balance the value of AI with its environmental impact? So does anybody want to start with an answer on that one? Otherwise, I have one, but...
I can start, this is one interpretation. I think that question, it's a great one. It has several layers, right, like an onion. So the environmental impacts, I get to meet with many of our communities and cities who are meeting with data centers as they come to Georgia and trying to understand, is this the right decision for our community, right, to allow rezoning requests, for example, to pass through the process. And so electricity usage, water usage, right, the taxes, like they consider all of those factors. And the water piece from an environmental perspective comes up a lot. I mean, sometimes I get to sit in these conversations and meetings and the electricity doesn't come up as much as the water because it is a very finite resource versus we can build some new plants perhaps. And so I think that's something that I've heard some of the water, I'm not going to speak for them, but I've heard them talk about how they have to plan ahead 50 years or so, and how sometimes their feedback, if a data center is looking at a certain location, the feedback from can the water usage desire be met feeds into the data center then saying, okay, well, I'll pivot, I'll use some different technology, cooling, air-cooled technology and so forth, or I'll design it slightly differently to reduce my footprint. And some of them are very water efficient now. So that's the only tidbit I'll add from environmental, but we can certainly take it a lot of directions.
I think I'll add to that too, that It's not just about AI and efficiency, it's about efficient use of AI. So the better developed the tools are, the more purposeful its use is. It may consume a bit of energy and water in the process, but if it saves substantially more energy, water, and it's elevating quality of life, where it's not AI for AI's sake, I think at that point it ends up being a net benefit, even though it is consuming scarce or in some cases resources. But I do think it's important that as we have these requests for interconnection, as they want to dip a straw into the aquifer, having above and subsurface tools like Sequent to really assess that as an impact is important. And I think also, like I said, as users or technologists around AI, us being really careful to make sure we're bringing efficient and purposeful to the market, not just creating more AI slop was, I think, the phrase I heard the other day, if anybody else has heard that. So we definitely don't want to be in that business. Anything else anybody would like to add?
Yeah, I mean, on our side, what we're looking at the European Union right now, so first of all, we have efficiency requirements for data centers already in place, which is helping quite a lot. And then we're looking at additional ways that they can actually be, as you mentioned, a net benefit. So first of all, talking about getting the electrification rate up, because in order to decarbonize our system, we have a goal here in Europe of decarbonization by 2050 for the whole economy, and data centers are going to play a huge part in that. And then taking, this cooling necessity, maybe turning it around and saying, okay, we have all this excess heat. In Europe, it gets pretty cold in the wintertime. And I remember this great campaign from Facebook back in 2009, 2010 that was like, your likes are heating Finnish homes. And so kind of, figuring out innovative ways to turn this on its head so it ceases to be, a huge net negative environmental impact, but rather we're taking advantage of everything that's being produced by it and turning it into a net positive.
District heating. It's amazing, isn't it? Co-locating those facilities with areas in need of heat is pretty awesome. Any other questions here from the audience or any other questions? Yes, we have a question here in the middle.
So I write about sustainability, and I'm based in the US. And we've talked about transmission and distribution. Generation concerns me because at the moment it seems like an awful lot of renewables and projects that have already been funded are being cancelled. Like large solar project, I think it's in Arizona, being cancelled. Offshore wind, Salem, Massachusetts, there was a big project cancelled. How, if you're making a 20-year plan for all of this, and with AI having a high demand for energy use, how do you factor in this volatility of an administration that comes in and all of a sudden things that are in the pipeline are now not in the pipeline, and how do you accommodate for the fluctuations in policy going forward?
Yeah, I think I'll lead on this one. I think it's important that we build, we're talking about all the ibles and capables, and when we talk about reliability and everything, I think the one thing that we didn't mention, but is a part of the conversation, is flexible. So we need to design a grid that is flexible for policy, that is flexible and adaptable to technology changes on the generation side, et cetera, because in some jurisdictions, the policy changes every year, every 2 years, every 4 years, every 5 years, 6 years, depending on how the government is formed and et cetera. So on the connective tissue of the grid, we're called to build a grid that can deal with many of these changes, because it's not just about a 4-year administration or 8 years or a 5-year parliamentary session. This is multi-generational, meaning grandkids of grandkids are going to be looking after this infrastructure. So to deal with that and the fact that it's going to always change, I think globally, is we have to build that flexibility into the grid so that we're not building a bunch of monotasking infrastructure, because no matter what will happen, then we're all going to be stuck with the changing winds, if I can be so punny. For
Unintended, huh?
That was very intentional. Yeah. So, and any last thoughts add to that?
Yeah, I'll add just one. I mean, it's recognizing, it's not just Georgia Power Southern Company, but our Public Service Commission believes very strongly in the diversification of fuel types. And so that also helps in a lot of different ways. But one is, an example, because we believe that, and that is a policy decision of our commission, we have different RFPs through which developers can bid in. So we have some that are renewable specific, some of them that are battery storage specific. We had a biomass proceeding within the last year. We also have one that is all fuel source type, so that they are from a cost perspective, evaluated specific to that resource type, and then we have one that's an all play. And so because we want to incentivize and see these different types of fuel types come into our state, because that does help us, whether it's a winter storm or what, we need all the above. So I think that's just one element, the tax incentives, for example, at a federal level absolutely will influence what these developers bid into and what their costs to do business are. The good news is if it is a renewable specific RFP, they're going to be compared against their other similar costs, right, that everybody's experiencing. But we believe strongly that we want to see more renewables, we want to see storage, we want to see biomass, right, we want to see that diversity, so.
All right, excellent. Well, that is all the time we have for today. I want to extend a great thanks to our panelists. Thank you for traveling near and far to join us here at Bentley's 2025 YII event. And to our audience, both here and remote, thank you for attending. I hope this is just the beginning of a conversation that we get to carry on until next year when we celebrate all of the great advancements that happen over the next 12 months. So thank you here, and thank you all as well. And enjoy the rest of your 2025 YII.
Thank you.
Thank you.